Dozens of fighter jets are flying toward your strategic ship. You immediately open fire on the enemy aircraft. However, the enemy planes are extremely agile, and your anti-aircraft system cannot hit them at all. After closing in, the enemy aircraft drop torpedoes onto your strategic ship. The torpedoes explode and destroy your ship. Fortunately, you survive. Afterward, you operate an aircraft carrier for a mission. The aircraft carrier uses heavy oil as fuel, and its flight deck has a flat structure. An observer detects dozens of enemy aircraft approaching your carrier, so you immediately order the carrier-based aircraft to take off. Because the flight deck is not long enough, high-pressure gas and pulley systems are used to accelerate the aircraft. After a long preparation time, all carrier-based aircraft finally take off and engage the incoming enemy jets. After a fierce battle, several aircraft run out of ammunition and need to land for resupply. However, the propellers of some planes get tangled in the netting, causing them to flip over. Since the deck is occupied, other aircraft cannot be serviced, allowing enemy planes to break through the defense line and successfully drop torpedoes, destroying your carrier. You once again survive by luck. Afterward, you command a more advanced aircraft carrier. It has a longer flight deck, and the bridge is moved to the side to form a separate island structure, improving visibility and increasing the safety of takeoff and landing operations for carrier-based aircraft. At this time, reconnaissance aircraft detect incoming enemy formations, and you immediately order your carrier-based aircraft to take off. A hydraulic catapult system uses high-pressure fluid to push pistons, accelerating the aircraft via steel cables to takeoff speed. The carrier aircraft engage the enemy jets and quickly destroy them. However, they are low on fuel and ammunition and begin returning to land. During landing, the tail hook catches the arresting cables, and the hydraulic system absorbs the massive force, allowing for smoother landings. Because multiple arresting wires are available, landing success rates are high. Just as operations are underway, another wave of enemy aircraft suddenly arrives. Since the carrier is busy with landing operations, no aircraft can take off to respond. Despite desperate preparations, the carrier is eventually hit and destroyed. You survive again and operate a new aircraft carrier. This one uses an angled flight deck, allowing simultaneous takeoff and landing operations. To support jet aircraft, it uses an angled deck layout. A radar detects incoming enemy aircraft, and you order carrier-based jets to take off. However, due to the heavy weight of the aircraft, fuel and missiles must be reduced for safe takeoff. After acceleration, the jets successfully launch and engage the enemy. But because they are not fully loaded, they must frequently return for resupply, placing your air power at a disadvantage. Eventually, enemy aircraft penetrate the defensive network and launch missiles, striking and destroying your carrier once again. You survive once more. After that, you operate another aircraft carrier equipped with a steam catapult system, using steam pressure to drive pistons and accelerate aircraft. You first launch an early warning aircraft to patrol the sky. It detects incoming enemy jets, and you immediately launch carrier-based fighters. Steam flows from the boiler into the catapult system, driving pistons at high speed. The massive acceleration makes pilots feel dizzy, but they are well trained. A large number of aircraft are launched and engage the enemy. Because of their superior numbers and full fuel and armament, they destroy the enemy aircraft and continue forward to attack the enemy carrier, which is quickly overwhelmed and destroyed. After victory, aircraft begin landing. When the tail hook catches the arresting wire, the system applies strong resistance to safely stop the aircraft. A pilot comments that the catapult force is too strong and uncomfortable during takeoff, suggesting it should be adjustable depending on the aircraft. Taking this feedback into account, you command a new aircraft carrier equipped with an electromagnetic catapult system. It uses electromagnetic force to provide more precise, efficient, and reliable launch capability. You first launch a heavy early warning aircraft. The control system adjusts the electromagnetic field according to its weight to ensure a safe takeoff. The airborne aircraft detects incoming enemy jets, and you order carrier-based fighters to launch interception missions. The system adjusts current levels to match aircraft weight. During combat, some aircraft run out of missiles and return for resupply. The arresting system applies control. After several days of sailing, the enemy base comes within striking range. You launch carrier-based aircraft using ultra-low altitude flight to avoid radar detection. The enemy is completely unprepared for an attack from the rear, and many of their aircraft are destroyed before even taking off. This time, you achieve victory. But suddenly, several hypersonic missiles appear in the distance.